Plastic waste is one of the biggest environmental challenges of our generation. Each year, millions of tons of plastic waste end up in landfills and oceans, posing a threat to ecosystems and human health. In addition, water hyacinth, an invasive aquatic plant, blocks everywhere, and rice husk ash, a byproduct of rice milling, is often underutilized and considered a waste product.
Constructing a regular clay or cement brick releases sulfur dioxide and other pollutants and particulates into the atmosphere, with brick kilns contributing to 2.7% of global carbon dioxide emissions. The extraction of clay depletes natural resources and leads to landscape degradation and loss of biodiversity.
But what if these waste materials could be turned into something more useful? In today's project, we'll explore how we can create what we call an eco-brick, a sustainable building material using a mixture of dried water hyacinth, rice husk ash, and plastic waste. These bricks offer an environmentally friendly alternative to traditional construction materials, reducing plastic pollution, greenhouse gas emissions, and agricultural waste.
Now let's walk through the method that we use to create an eco-brick. Step 1. Collecting the materials. First, we gather the three main components. First is the water hyacinth that is collected from the nearby water bodies and left to dry. Second, rice husk ash, which is sourced from rice milling processes. And lastly, plastic waste that is cleaned and cut into small pieces. Step 2. Preparing the water hyacinth. The water hyacinth was first dried under the sun for around a week. Then the dried water hyacinth is then chopped and blended into smaller pieces. Now, step 3 is preparing the rice husk ash. The rice husks are placed on an aluminum sheet and burned with lit cotton balls covered in gasoline. After burned, it is left to cool for a few minutes and then crushed into a fine powder.
Next, we combine the dried water hyacinth and rice husk ash to make a biomass mixture that strengthens the brick. The ratio of the dried water hyacinth to the rice husk ash used to make the mixture is 3 to 2. 600 grams of the dried water hyacinth and 400 grams of the rice husk ash are used and mixed to make the total biomass of 1 kilogram.
We heat it around 1.2 kg to make 2 bricks of shredded plastic in a pan. The biomass mixture is then poured into the melted plastic whilst the heat is still on. The plastic waste, which melts under heat, will form the core structure of the eco-brick. The heat must remain on to prevent the plastic from solidifying. After the biomass is mixed with the plastic waste well, the new solution is poured into a brick mold and left to cool and solidify.
These eco-bricks can be used in various construction applications such as paving walkways, building walls, and more.
Our eco-brick addresses two main environmental issues: plastic pollution and agricultural waste. First off, plastic waste. Instead of letting plastic waste accumulate in landfills, we can repurpose it into a more useful material for construction. Secondly, agricultural byproducts. Water hyacinth, often seen as a nuisance, and rice husk ash, typically discarded, are both utilized effectively, reducing waste and creating value out of what people think as nothing.
In conclusion, eco-bricks offers an innovative and eco-friendly solution to the challenges of waste management and construction. By repurposing materials that are often considered pollutants, we not only help clean the environment, but also create a sustainable alternative for building materials.
The practicality of this brick is 1. Easy to find the materials, and 2. A cheaper alternative in making bricks. The functionality of this brick is 1. Adding the role of a brick by reusing the wasted materials, and 2. Reducing pollution. The next step in this project is further testing, exploring the brick's durability, water resistance, and potential large-scale applications. With continuous development, eco-brick could become crucial to sustainable architecture and environmental conservation. After further testing with the help of a pressure test, these are the relative strength of a few biomass ratios. These are the following graphs from the survey that we did. Based on the building materials market share and trend analysis report, surprisingly the demand of commercial brick is quite high. Adopted from this, the demand of eco-brick is also quite high as the time goes by, forecasted until 2030. So this invention is very promising with a proper business plan.